Picture this. You're in the middle of the North Sea. The waves are churning, the wind is just howling, and you've got this massive 10,000-ton vessel that has to stay perfectly still just a few meters from an oil rig. I mean, there is absolutely no room for error. It's this incredible dance between human and machine. But what happens when that dance goes wrong?
Seriously, how do they do it? It's not like they can just drop a giant anchor. No, the tech that makes this possible is way more complex. And honestly, it's pretty incredible when you think about it.
It's called dynamic positioning, or DP for short. And basically, it's this brilliant mix of satellite navigation, a ton of sensors, and really powerful thrusters. And it's all orchestrated by a central computer that's making thousands of calculations every single second. It's like the ship has its own brain and muscles, all working together to fight against the power of the ocean.
All right, so let's get into what happens when this amazing technology actually fails. We're going to dig into a really important report from 2009 that looked at dozens of these high-stakes incidents. We'll check out the data, figure out why the machines failed, explore the critical human element, and most importantly, see what lessons we can learn from it all.
So let's start with the big picture, right? We're going back in time to 2009, and we're looking at all this through the lens of a major industry report. This thing collected data on station-keeping incidents from all over the world, and it gives us this unique snapshot of where these incredibly complex systems were breaking down.
So in that 1 year, 75 separate incidents were reported and analyzed. Now, the report itself says this is probably just the tip of the iceberg, because of underreporting. But still, 75 gives us a really solid data set to start understanding where the weak spots are.
And this is where it gets really interesting. When you look at what caused these failures, it's not just one thing. They pretty much fall into two main camps. You've got the technology itself, the position reference systems, the power, the propulsion, and then you have the other big piece of the puzzle, the human element, which you can see right there as human error.
Let's talk about the machine first, because if you look at that chart again and you add up all the technical problems, power, propulsion, all of it, they account for the vast majority of these incidents. This is where the actual hardware is letting the crew down.
And the top 3 technical culprits are crystal clear. Number 1, at almost a quarter of all failures, were the position reference systems. These are basically the ship's eyes and ears, the GPS, the lasers, the sensors that tell it exactly where it is. Right behind that, you have power, the ship's heart, its generators and electrical grid, and then propulsion, the muscles that actually push against the sea.
Now here's the thing. These huge system-wide failures, they often start with something incredibly small. Just listen to this quote from one of the incident reports. A multi-million-dollar vessel loses control all because of one single defective circuit board. And the cause? Just normal wear and tear.
And this list just shows you how wild and varied these problems are. It's not one single flaw showing up over and over. You've got corrosion on a sensor because of where it was mounted, a simple cooling fan dying on a power supply, a single bolt vibrating loose, a faulty pressure sensor, a tiny relay failing. I mean, any one of these seems minor by itself, but each one is a ticking time bomb with potentially catastrophic consequences. It really drives home how critical good maintenance is. But it's not all about rusty bolts and bad electronics. You can have the most advanced system on the planet, but there's still a person in the loop. So let's talk about that other major cause from our chart, the human factor. At 13%, human error was a huge deal. In fact, it was responsible for just as many incidents as all of the electrical system failures put together. That tells you, right there, that the connection between the operator and the machine is just as critical as any piece of hardware on board. And this slide, this is just a perfect, almost unbelievable example. The goal is simple. Keep the ship steady. The action that caused a major incident? Somebody put a logbook down on the control console and it accidentally pressed a critical switch. That's it. A simple, unintentional mistake that sent a massive, unintended command to the whole system.
And this wasn't just a one-off. The report shows a clear pattern. You see operators shutting down the wrong generator during a test, getting distracted during a crucial shift change, and in 2 separate incidents on the same vessel, an operator entered a command twice because a little dialog box was left open on the screen. It's a stark reminder that even the best, most highly trained operators are still human, especially when they're under pressure.
So what's the big takeaway from all this? I mean, the real value of sifting through these 75 incidents isn't just to make a list of what went wrong. It's about using that data to find the patterns, to see the warnings before they turn into full-blown catastrophes.
And that's the crucial point, right here.
When the same piece of equipment or the same system fails multiple times, it stops being a random accident. It becomes a data point. It's a huge flashing warning sign that there's a deeper, systemic problem that you absolutely have to address.
Let's look at this case study, which the report specifically highlights. The exact same model of microwave radar, a really key sensor for positioning, was involved in 5 separate incidents. And get this, the immediate causes were all different. A bad card here, a power supply there, wrong frequency. But the pattern? The pattern was unmistakable. The same piece of gear kept failing.
And here is the payoff. Because they were tracking these seemingly random incidents, the vessel operator was able to zoom out and see the bigger picture. They realized the system itself was the problem, and they started a fleet-wide program to replace it. And that, right there, is the power of learning from data. You turn individual failures into collective intelligence.
All of which leaves us with a final, really important question to think about. I mean, this data is from over a decade ago, and technology has only gotten more complex and more automated since then. So as we go forward, where do we place our bets? Do we try to build the perfectly flawless machine, or do we focus more on training and empowering the human operator who has to manage it all when things, inevitably go wrong? The answer is probably a bit of both, but finding that perfect balance, well, that's something every high-stakes industry is still trying to figure out.